Hey guys, welcome to another video where I'll be teaching math. I'm Abhinav. I've done both my bachelor's and master's in electrical engineering from IIT Kanpur. This video is about solving the JEE Advanced sample paper released by IIT Kanpur for the upcoming JEE 2025 exam. The paper released by the institute is a very difficult one and it is much harder than the toughest JEE exam of all time, JEE Advanced 2016. The video is lengthy because I made sure I explain everything from very basic so that it will be understandable and helpful for everyone watching the video. There are awesome questions in this question paper which really boggles your mind and make you think very critically in order to solve them accurately. If this is the kind of question paper they set for the actual exam, scoring even 50% is also a big thing. Even from a very basic topic like quadratic equations, they managed to set wonderful questions. The way they tested you about definite integrals, local maxima, local minima, and other topics is simply wonderful in this question paper. So do not miss anything from this session. It will only help you for your actual exam. And if you get a similar question in your exam, it will be a cakewalk for you. So stay tuned till the end and get the most out of it. If you have any queries about any question, comment section is the way to go. Genuine feedback is much appreciated. So let us get started. Paragraph questions are the best way to score some marks in the examination. Your goal in the examination is not to solve all the questions in the question paper, but to solve those easy questions where you can score the maximum marks. And paragraph questions provides a way for you to do exactly that. Because if you take this particular paragraph question set by IIT Kanpur in its sample paper as an example, so it has got two follow-up questions. And if you are able to solve these two questions, you will easily get 8 marks. Let's say you are solving two multiple choice questions or two single correct answer questions. So if you have to solve two questions, you have to switch between two different concepts. And there will be a lot of option checking. So if it is a multi-correct answer question, you have to check all the options and it takes a lot of time as well. But if you're solving a paragraph question, it is based on the same concept and you have to solve two questions based on that particular concept. There is no switching between different concepts and all of that stuff. So I strongly recommend you guys to solve either paragraph questions or matching questions in your examination first, because they'll give you some easy marks and your ultimate aim is to score marks in an examination. All right, so let us go ahead and solve this paragraph question. I think this already appeared. This is a previous year question. So let us see. We have two football teams, T1 and T2. They play games against each other. It is assumed that the outcomes of the two games are independent. The probabilities of T1 winning. So these are the probabilities of T1 winning and drawing and losing a game against T2 are 1 upon 2, 1 upon 6 and 1 upon 3. Each team gets 3 points for a win. If you win, you'll get 3 points. If 1 point for a draw, if you lose, you'll get 1 point and 0 points for a loss of a game. Alright, let X, Y denote the total points scored by teams T1 and T2 respectively after 2 games. So the total number of games played are 2 and the points scored by each team is counted after the 2 games. And X is the point scored by team T1, Y is the point scored by team T2. Now we have to find the probability that X is greater than Y and probability that X is equals to Y. Alright. So I made a table out of it. This is how you have to interpret. I recommend all of you to draw these kind of tables or to interpret the information in some meaningful way before solving the question, because once you do this particular exercise, it will take very less time for you to solve that particular question. All right, so this is for match 1 and this is match 2 and T1 T2 are the teams. So in match 1, so the possibilities are T1 wins and T2 loses, or T1 loses and T2 wins and they end up in a draw. These are the only 3 possibilities. So there cannot be win-win because both teams cannot win at the same time. All right, so in this particular case, in the second match, T1 can win and T2 can lose, or lose and win, draw. So these are the 9 possibilities that we have, and here I made 2 columns for the scores at the end of 2 matches. All right, so now let us consider the first case. Win, T1 wins and in the second match also T1 wins, so it will get 6 points. So for T2 it is both loss, so 0 points. And for the second case, T1 wins here and T2 loses here, so 3 points. And for T2 lose and win, so 3 points. For the third case, win and a draw, so 4 points. Lose and a draw, so 1 point. Loss and win, 3 points. Win and loss, 3 points. Loss and loss, 0 points. Win and win, 6 points. Loss and draw, 1 point. Win and draw, 4 points. Draw and win, 4 points. Draw and loss, 1 point. Draw and loss, 1 point. Draw and win, 4 points. Draw and draw, 2 points. Draw and draw, 2 points. So now what do we have to find out? We have to find out P of x greater than y and P of x is equal to y. Let us see where x is greater than y. So this is one case in which x is greater than y, and this is the second case, and this is the third case. These are the three cases in which x is greater than y. So now let us try to find out the probabilities. So the probabilities of T1 winning, losing and ending up in a draw is given to us. Win is 1 by 2, draw is 1 by 6. Win is 1 by 2, draw is 1 by 6 and loss is 1 by 3. So in the first favorable case, which is this case, so in the first match P1 wins. So the probability of that happening is 1 by 2. It is given here, 1 by 2. Even in the second match it wins, so multiplied by 1 by 2. Plus, let's go to the second case, which is this particular case. Alright. So here in the first match P1 wins, so the probability is 1 by 2, and in the second match it ends up in a draw. The probability is 1 by 6. Plus, let's go to this particular case. Here in the first match P1 ends up in a draw, so the probability is 1 by 6. In the second match it wins, so the probability is half. So this is the probability P of x greater than y. This is given as P in the question. So P is equals to 1 by 4 plus 1 upon 12 plus 1 upon 12. So that is simply 12, 4 3 is 12 plus 1 plus 1. So this is 5 upon 12. Your P is 5 upon 12. Now we have to find out the probability that P of x is equal to y. So what are the favorable cases? So this is one favorable case. I'll do it with a different color. This is one favorable case. This is one favorable case. And this is another favorable case. So we have three cases. So if we go with this particular case, T1 wins and T1 loses. So probability of winning is 1 by 2, losing is 1 by 3. So 1 by 2 multiplied by 1 by 3 plus, in this particular case it loses and wins. So the probability is 1 by 3 multiplied by 1 by 2 plus, in this particular case it ends up in a draw. So the probability of draw is 1 by 6 multiplied by 1 by 6. So this is P of x is equal to y, and this is given as Q in the question. So Q is equals to, so this is 36. So LCM will be 36. So here you'll get a 6, and here also you will get a 6 plus 1. Alright. So this will be 13 upon 36. So Q is equal to 13 upon 36. P is equal to 5 upon 12. So P is equal to 5 upon 12. So 36P will be 15. So 72Q. Q is 13 upon 36. So 72 times Q is 26. So the answer to the first question is 15 and answer to the second question is 26. Alright. So let us go ahead and solve these three questions. So these questions appeared in the numerical section of the sample paper. So let us go ahead and try solving these questions. So it looks, the question looks very clumsy. So it looks like there is a lot of information given. So whenever you encounter these kind of questions, the trick is to maintain your calm and to not get panicked by seeing a lot of information given in the question. You try to carefully interpret the question, try to understand what is given, make sense out of it, and then try solving it. Most of the times these questions can be solved very easily. All right, so let us go ahead and solve this question, 12th question. So you have an ellipse given, x square by 6 plus y square divided by 3 is equal to 1. Pretty standard ellipse. All right, so it is a horizontal ellipse. Your E1 denotes the locus of points of intersection of the pair of perpendicular tangents. So you're drawing perpendicular tangents to this ellipse and at different points, and your like E1 is the locus of those points of intersections of perpendicular tangents. That is simply a director circle. So that is the definition of director circle. All right, so what is the equation of director circle? The equation of director circle for an ellipse is x square plus y square is equals to a square plus b square. Here a square is 6, b square is 3, so this is 9. So you will have a director circle something like this. All right, so this is 3 comma 0. So now E1, we have figured out what E1 is. All right, now let us go ahead. The vertical line passing through the point h comma 0 intersects E and E1. So this is E, this ellipse is E, and the circle is E1 at Q and R respectively. So you are drawing, so there is a point h comma 0 and you are drawing a vertical line passing through this h comma 0. This intersects E and E1 at Q and R. So this point is Q and this point is R. All right, in the first quadrant. Sure. Now let the tangent to the ellipse at point Q. So you are drawing a tangent to this ellipse at point Q and it meets the x-axis at point T. So this is point T. Delta H be the area of the triangle PRT. So this is point P and you have to worry about this particular triangle. So this is the triangle PRT. This is the triangle PRT. Obviously this is a right angle triangle. This is the first, that is the first observation you should make. Now delta 1 is the maximum area of this triangle when h varies between 1 and 2, and delta 2 is minimum area of this triangle. All right, so h varies from 1 to 2. Let us say so this point is root 6 comma 0, root 6 comma 0. So root 6 is greater than 2. Since h lies between 1 and 2, this point P always lies inside the ellipse. So let us try to find out what the area of triangle PRT is. So let us assume point Q as root 6 cos theta comma root 3 sin theta, since it lies on the ellipse. Then your h will be root 6 cos theta. All right, then your r, let us try to find out r will be root 6 cos theta comma, so we know the equation of the circle, green circle, x square plus y square is equal to 9. So if you put root 6 cos theta here, you will end up getting the y coordinate as 9 minus 6 cos square theta. So we know r also. And let us try to find out the point T as well. What is point T? So let us try to find out the equation of tangent. What is the equation of tangent of an ellipse? X1 by 6 plus y1 by 3 is equal to 1. Here x1 and y1 are the vertices of the point Q. So that is x into root 6 cos theta by 6 plus y into root 3 sin theta by 3 is equal to 1. So this is x cos theta upon root 6 plus y sin theta upon root 3 is equal to 1. Since we have to find out the point T and it lies on the x-axis, let us substitute y is equal to 0 in this particular equation. Then you'll get x is equals to root 6 upon cos theta. Alright, root 6 upon cos theta. So the coordinates of point T are root 6 divided by cos theta, comma 0. Now we have to find out area of the triangle PRT. So that is simply a right angle triangle. The formula will be half into base into height. Base is PT multiplied by height is PR. Half into PT will be, let's say this is origin, OT minus OP. OT minus OP. PT is this whole length OT minus this length OP multiplied by PR is the y coordinate of this point R. So root of 9 6 cos square theta. This is delta of H. So half into, what is OT? OT is root 6 by cos theta minus OP. OP is root 6 cos theta. Root 6 cos theta multiplied by square root of 9 minus 6 cos square theta. This is the formula for the area of the triangle delta. So now it is given that 1 is less than or equal to H is less than or equal to 2. But what is H? H is simply root 6 cos theta. So 1 less than or equal to root 6 cos theta less than or equal to 2. So 1 upon root 6 less than or equal to cos theta less than or equal to 2 upon root 6. So cos theta lies between these two values. Alright. So now if you can easily check. So if P is somewhere here, this triangle area will be more. Let's say if T is somewhere here, we'll draw a tangent here and it decreases. This triangle area decreases. So when you move from left to right, the triangle area decreases. So for cos theta is equals to 1 upon root 6, the triangle area will be maximum, and for cos theta is equals to 2 upon root 6, the triangle area will be minimum. Alright. So now let us go to this and find the maximum value. To find the maximum value, you have to put cos theta is equal to root 6. So this is 1 by 2 into root 6 by 1 by root 6 is root 6 minus root 6 multiplied by 1 by root 6 into square root of 9 minus 6 into 1 upon 6. So this is simply 1 by 2, this is 6 and this is 1 multiplied by 5, this is 9 minus 1, root 8. So this is root 8 is simply 2 root 2, this 2 and this 2 gets cancelled. So this is 5 root 2. So the max value. So let us find the minimum value of the area. So to find the minimum value, we have to put cos theta is equal to 2 by root 6. So delta minimum is equal to half into root 6 by cos theta. Cos theta is 2 by root 6. So minus root 6 cos theta is 2 upon root 6 into square root of 9 minus 6 cos square theta will be 4 upon 6. So this will be 1 by 2. So this is 6. 6 upon 2 is 3 minus. So this is 2 and this is 9 minus 4 which is 5. So this is root 5 upon 2. Alright, this is the maximum value and that is the minimum value. Now we have to find out delta 1 square. So maximum value whole square, which is 5 root 2 whole square. 5 root 2 whole square minus 4 into delta 2 whole square, minimum value whole square. Root 5 by 2 whole square is 5 by 4 simply. So this is 5 square is 25. 25 times 2 is 50 minus this and this gets cancelled 5. So which is simply 45. So the answer to this particular question is 45. So let us proceed to the next question. Okay. So what is given in this question? So you have this expression given 25 minus x whole power 100 plus 1 plus 25x whole power 100. So this is the expression that is given to you. And when you expand this, you'll get something like this. Alright. If an is less than 0, so an is less than 0 for some positive integer n. For some n. Alright. For 0 less than n less than is equal to 100. So the maximum possible value of n is, let us find out the general form of an. So if you consider this, what will be the coefficient of x power r? The coefficient of x power r is 100 c r into 25 power 100 minus r into minus 1 whole power r. So this is the coefficient of x power r for this particular term. And similarly, for this particular term, the coefficient of x power r will be 100 c r multiplied by 25 power r. So this is the coefficient of x power r. So the coefficient of x power r for this total summation will be 100 cr 25 power 100 minus r into minus 1 whole power r plus 100 cr 25 to the power r. So the coefficient of x to the power r will be simply ar. So this is ar. Ar is equal to this. So it is given that an is negative. So this is negative. So how can this be negative? This is always positive. This will only be negative when, let us say this is an. So then you will have to replace r with n. Alright. So when will this be negative? This will be negative only when this n is odd. So n is odd. So n is equal to odd. So this minus 1 whole power n will simply be replaced by minus sign. Alright, now since it is given that an is negative, so we can write 100 cn 25 power r minus 100 cn 25 power 100 minus n less than 0. Alright, so 100 cn 100 cn, it gets cancelled because it's like you can take this 100 cn common, and since it is a positive thing, you can take it to the other side. So 25 power n less than 25 power 100 minus n. So 25 power n less than 25 power 100 divided by 25 power n. So 25 power 2n less than 25 power 100. So 2n less than 100, n less than 50. So we got n less than 50. We already know that n is odd, and they asked us to find out the maximum possible value of n. So n should be less than 50 and it should be an odd number and a maximum value. So n will be 49. You can consider n is equal to 47 also, but that will not be the maximum value of n. So the maximum value of n is 49. It is a simple question based on binomial coefficients. You should be able to easily do it. This is 49. So let us proceed to the next question. So in the next question, again, there is a lot of information given in the next question. The trick is to not get confused. The trick is to maintain your calm during the examination and go ahead and solve the question. Alright. So consider a closed interval 0 to 1. So you have a closed interval. Here you have 0 and here you have 1 labeled as C0. So this is C0. In the next step, divide the interval 0 to 1 into 3 parts. So let us divide this interval into 3 equal parts actually. So let us divide this interval into three equal parts. So here you have 1 by 3, here you have 2 by 3, and delete the middle interval. So you are deleting this middle interval. Let C1 be the union of the two intervals. So C1 is union of this particular interval and this particular interval. Similarly, construct Cn, divide each interval of Cn minus 1 into 3 parts. So if you have to construct C2, so what is your C1? Your C1 is these two intervals. All right, so this interval and this interval, so you have to divide this into 3 equal parts. All right, so you have to divide, let's say you have to divide this into 3 equal parts and this interval also into 3 equal parts. And now delete this middle interval and also delete this middle interval. So your C1 will be your C2 will be this plus this plus this plus this. All right, now we have computed, so similarly we can compute C3, C4 and so on Cn. If Ln denotes the sum of the lengths of the intervals in Cn, okay, so sum of the lengths of the interval in Cn, so L0 will be this total length 1, so L1 will be sum of the lengths of these two intervals, so that is 1 by 3 plus 1 by 3. Similarly L2 will be sum of the lengths here, so this is 1 by 9 plus 1 by 9 plus 1 by 9 plus 1 by 9. Okay, if you see L0 is 1, L1 is 1 upon 3 plus 1 upon 3, L2 is 1 upon 9 plus 1 upon 9 plus 1 upon 9 plus 1 upon 9. So here this one interval generated 2 intervals and these 2 intervals generated 4 intervals. So from each interval you will generate 2 more intervals. So in L3 you will have this, each interval will generate 2 more. Alright, so you will have 8 such intervals. And what is the length of each interval? So this divided by 3. So this 1 divided by 3 is the length of interval in L1 and 1 by 3 divided by 3, which is 1 by 9, is the length of interval in L2. So here it will be 1 by 9 divided by 3, which is 1 by 27 plus 1 by 27 plus and so on 8 times. Alright, so this is 1, this is 2 by 3, this is 4 by 9, this is 8 by 27. So if you observe carefully, in the numerator you will get, you have 1, 2 power 0, 2 power 1, 2 square, 2 cube. In the denominator you have 1, which is 3 power 0, 3 power 1, 3 square, 3 cube. It is simply, this is simply 2 by 3 whole power 0, this is 2 by 3 whole power 1 and this is 2 by 3 whole square and this is 2 by 3 whole cube. You got a really nice pattern. Now they are asking us to find out sigma r is equals to 0 to infinite minus 1 whole power r plus 1 r times lr. So let us say this is I. Okay, when you put r is equal to 0, this is minus. So minus 1 times 0 times L0. So that will be 0. When you put r is equal to 1, it is L1. When you put r is equal to 2, it is 2L2. When you put r is equal to 3, it is 3L3. When you put r is equal to, so similarly you'll get something like this, 4L4 plus and so on till infinite. This is equal to I. So L1 is 2 upon 3. So this is 0 plus 2 upon 3 minus 2 times 2 upon 3 whole square plus 3 times 2 upon 3 whole cube minus 4 times 2 upon 3 whole power 4 plus and so on is equal to I. This is an infinite arithmetic geometric progression, AGP, and you know how to solve AGPs. Okay, simply multiply both sides with 2 by 3. So what do we get then? So we'll get, if you multiply this thing with 2 by 3 on both sides, you'll get 2 by 3 whole square minus 2 times 2 by 3 whole cube plus 3 times 2 by 3 whole power 4 plus and so on is equals to 2 by 3 upon 2 by 3 multiplied by I. Now add these two equations. So you'll get 2 by 3 and this will be minus 2 by 3 whole square plus 2 by 3 whole cube plus and so on. This will be 5 by 3 multiplied by I. Now this is an infinite geometric progression, and what is the common ratio? Common ratio is minus 2 by 3. What is the formula for sum of infinite GP? So that is simply a by 1 minus r. A is the first term, which is 2 by 3, by 1 minus r is minus 2 by 3. So this is 2 by 3. So this is 5 by 3 I. So this is 2 by 3 into 3 upon 5 is equals to 5 upon 3 I. This and this gets cancelled. So this will be simply 6 upon 25. This is I. You can convert this into a decimal value and you can put the value here, 6 upon 25. How much will that be? 0.024. So that is your answer for this question. So these are all easy questions. This question is based on simply the binomial coefficients, and here you don't have to do anything. You have to just interpret the question and know the area of the triangle for a right angle triangle, and here it is simply finding out the pattern, and you'll end up getting an infinite AGP, and you have to just algebraically find the sum. That's all. This question is from the topic quadratic equations, a very basic concept which everyone should know. So let us go ahead. So it is given that t belongs to open interval 0 comma 1 by 2, and there is a quadratic equation in x that is given to you. So t minus t square multiplied by x square minus 1 minus t times x plus t square is equals to 0. And the roots of this quadratic equation are alpha t and beta t. Then which of the following statements are false? They are asking you to find out the false statements. Alright, so your quadratic equation generally looks something like this: ax square plus bx plus c is equal to 0. So generally these a, b, c will be constants, but here these are functions of t. Let us say f of t, g of t and h of t. In the first option, they are asking you to check whether p of x has distinct roots or not. So let us find out the discriminant. Discriminant is equals to b square minus 4ac. So let us take 1 minus t common. So here you will get 1 minus t and here you will get minus 4. So this is t times 1 minus t. So 1 minus t came out, so it will be 4t cube simply. So this is 1 minus t multiplied by 1 minus t minus 4t cube. Now we have to check whether this discriminant is greater than 0, less than 0 or is equals to 0. Alright, so it is given to us that 0 less than t less than half. So if t lies between 0 and half, this quantity will always be positive. Alright, now we have to check for this particular quantity. Alright, so multiply this with minus, then you will get minus 1 by 2 less than minus t less than 0. So multiply this with right. Now this gives us 0 less than t square less than 1 upon 4. So if you multiply these two equations, it gives us 0 less than t cube less than 1 upon 8, or minus 1 upon 8 less than minus t cube less than 0, or minus 1 by 2 less than minus 4t cube less than 0. And if you multiply this with minus, you will get minus 1 by 2 less than minus t less than 0. So now add this and this. You will get minus 1 less than minus t minus 4t cube less than 0. Add 1 on both sides. Add 1 to this inequality. Then you will get 0 less than 1 minus t minus 4t cube less than 1. So this particular quantity 1 minus t minus 4t cube always lies between 0 and 1. So this is also positive. Therefore, we achieved that the discriminant is greater than 0. This implies that roots are real and distinct. All right. So here in the first option, they are saying that it has distinct roots. So this statement is true. This statement is true. Let us proceed to the next statement. For infinitely many values of t, the corresponding root alpha t is rational, and for infinitely many values of t, alpha t is irrational. Let us see what alpha t is. Alpha t is minus b plus or minus root of b square minus 4ac. So that is simply root of delta by 2a. Alright. Now, so this delta is simply a fourth degree polynomial. This is a fourth degree polynomial. This is a fourth degree polynomial, and t belongs to 0, 1 by 2. So there will be infinitely many values in between 0 and 1 by 2. And for some values, since this delta is continuous function and it is a fourth degree polynomial, for some values of 0 and 1 by within the interval 0 and 1 by 2, for infinitely many values, this quantity will be rational, and for infinitely many values, this quantity will be irrational because of this square root. All right. Therefore, the second option is also correct. Let us proceed to the third option. Alpha t and beta t are real and positive with both alpha t and beta t less than 1. So they are real. So this we have achieved in the first option itself while checking the first option itself. Now we have to check whether they are positive and both of them are less than 1 or not. Okay, let us check that. So to check whether alpha t and beta t both are positive or not, what we have to do, what we can do is, let us see what the product of the roots are. Alpha t multiplied by beta t is the product of roots. So the formula will be c by a. So t minus t square. So this will be t by 1 minus t. T is positive and 1 minus t is also positive when t belongs to 0, 1 by 2. So alpha t multiplied by beta t is greater than 0. This implies either both roots are positive or both roots are negative. So we have these two choices. So let us assume both roots are positive. So then our parabola looks something like this. If both roots are negative, our parabola looks something like this. So in this case, the vertex of the parabola, that is the turning point of the parabola, will be, the x-coordinate of the turning point of the parabola will be positive. And in this case, the x-coordinate of the turning point of the parabola will be negative. So let us find out the turning point. The formula to find out the turning point, x-coordinate of the turning point of the parabola is minus b by 2a. So that is minus b is 1 minus t divided by 2a. A is t minus t square. So this is t times 1 minus t. So 1 minus t and 1 minus t will get cancelled. So 1 upon 2t. So since t lies between 0 and 1 by 2, this x coordinate is positive. So therefore this turning point is positive, and hence both roots are, we can conclude that both roots are positive. So they are both real and they are both positive. These two are verified. Now we have to check whether they are both less than 1. All right. So let us say, now we know they are both positive. So let us say our parabola looks something like this. So this is one root and this is one root. So if both of them are less than 1, then 1 should lie somewhere here. All right. So let us find out what f of 1 is, so sorry, p of 1 is, so p of 1 is equals to t minus t square minus 1 plus t square. This and this gets cancelled. It is simply 2t minus 1. And since t lies between 0 and 1 by 2, 2t lies between 0 and 1, and 2t minus 1 lies between minus 1 and 0. So therefore p of 1 is negative. But in this case we see that p of 1 is positive if 1 lies here. So it means that 1 doesn't lie here. Also 1 doesn't lie here. Even if 1 lies here, p of 1 has to be positive. Only if 1 lies somewhere here, only in that case p of 1 is negative. So therefore one root is less than 1 and the other root is greater than 1. So this statement is false. Alright. Now here we have to find the difference of roots, alpha t minus beta t. Okay, let us find the difference of roots. So we know that alpha minus beta whole square is equals to alpha plus beta whole square minus 2 alpha beta. So alpha plus beta is simply sum of roots, which is minus b by a. So that is 1 minus t by t minus t square whole square minus 2 alpha beta is c upon a, which is t square by t minus t square. Alright. So this is simply t into 1 minus t. So this 1 minus t gets cancelled, and this will simply be 1 by t square minus 2 t square. This is simply t into 1 minus t. So this t and this t gets cancelled, so it will be t upon 1 minus t. So alpha minus beta whole square is this particular quantity. So mod of alpha minus beta will be square root of this. Now when you have to compute this, so t tends to 1 by 2 minus. So let us put t is equals to 1 by 2 in this. Then you will get root of, this will be 4 minus 2 into 1 by 2 upon 1 by 2. So this is simply 4 minus 2, which is root 2. Alright. So therefore this statement is also false. So the correct answers are C and D. Alright. Now let us move to the next question. So this is a very interesting question from the topic definite integration. So you have two integrals given. I of n is equals to integral 0 to infinite 1 by e to the power x plus e to the power minus x whole power n dx. And this function, this integral is also given. F of p comma q is integral 0 to 1. So if you observe carefully, this integral has the limits 0 to infinite, and this integral has the limits 0 to 1. And we have to, so it is, this is given, I22 is f of alpha comma beta by gamma. So we have to somehow transform the integral in into integral fpq. So this sort of transformation has to be done. The moment you see that you have to make this sort of transformation I to f, you have to start thinking about the limits. Alright. So here you have the limits as 0 to infinite. So now where do you see infinite? So you have to somehow make a clever substitution. So let us consider sine theta. There you will not see infinite. Cos theta you will not see infinite. Tan theta. Now that is where you get an infinite. So now if somehow you're able to bring tan theta into the picture, this infinite will get eliminated, and somehow you will get some kind of definite limits, and then we can, like, we will be closer to this, we will get closer to this integral, at least with respect to the limits. So let us try to simplify this. This will be integral 0 to infinite e to the power x whole power n dx by e to the power 2x plus 1 whole power n. Alright, so this can be written like this. So now again, so by looking at this infinite, I got an idea that somehow I have to bring tan theta into the picture. Now look at this term in the denominator. Now by looking at this term, so it should strengthen your conviction that you have to use tan theta, because if you put e to the power x is equal to tan theta, this bottom part, the denominator becomes tan square theta plus 1. So that is simply secant square theta. So it is getting simplified. So like by looking at that, you should confidently go ahead with the substitution. All right. So now let us substitute e to the power x is equals to tan theta. So therefore e to the power x dx is equals to secant square theta d theta. All right. Now this integral in will be integral when x is equal to 0, tan theta is equals to 1 and theta is equals to pi by 4. When x is equals to infinite, tan theta is equal to infinite and theta will be pi by 2. So now e to the power x is tan theta. So the numerator will be tan theta whole power n and dx is secant square theta d theta divided by e power x, that is tan theta by e to the power 2x is tan square theta plus 1. Tan square theta plus 1 is secant square theta whole power n. Alright, so you have tan thetas and secant thetas. So let us simplify it a bit. So this runs from pi by 4 to pi by 2. Tan theta whole power n minus 1 and secant theta whole power 2 minus 2n d theta. So this is the integral you have. So let us convert tan theta and secant theta into sines and cosines. So this is pi by 4 pi by 2. So sine theta whole power n minus 1 by cos theta whole power n minus 1 into 1 by cos theta whole power 2 minus 2n d theta. So let us bring the cos theta to the numerator. So pi by 4 to pi by 2 sine theta whole power n minus 1 cos theta whole power minus 2 plus 2n minus n plus 1 d theta. So 2n minus n is simply n, minus 2 plus 1 is minus 1. So this is cos theta whole power n minus 1. Alright, so this is d theta. Now if you look at this, so you have p minus 1 and q minus 1. So okay, here also we are getting n minus 1, n minus 1. So I feel we are going towards the solution. Alright, so now what can be done? Okay, so this is in. Alright, so let us see what I22 is, because that is what is given in the question. So I22 is pi by 4 to pi by 2 sine theta whole power 21 multiplied by cos theta whole power 21 d theta. These are very famous integrals. So you can put sine theta is equal to t, then cos theta d theta is equals to dt. So this will be 1 by root 2 and this is 1. So this is t to the power 21 and cos theta d theta is dt. So you will have cos theta whole power 20. Cos theta whole power 20. So this is same as cos square theta whole power 10. This is same as 1 minus sine square theta whole power 10. So that is 1 minus sine square theta is t square whole power 10. Alright. What we can do is, since we have 1 minus x in the question, so we can put t square is equal to p. So 2t dt will be dp. So therefore, so this is 1 by 2 and this is 1. Since t square is p, this is p power 10 into root p into 1 minus p whole power 10. So dp by 2 t is root p. So this and this gets cancelled. This is simply 1 by 2 to 1 p power 10 1 minus p power 10 dp. So let us replace p by x. So 1 by 2 to 1 x power 10 1 minus x whole power 10 dx. So we have x power 10 1 minus x whole power 10, all of that. Only there is only problem with limits now. So in the question we have limits from 0 to 1, but here it is from 1 by 2 to 1. Alright. So now let us see. This can be written as 1 by 2 to 1 x minus x square whole power 10 dx. Now let us try to draw the graph of x minus x square. At x is equal to 1 by 2, this is 0 and this is 1. At x is equal to 1 by 2, this will be 1 by 2 minus 1 by 4, that is 1 by 4 somewhere here. At x is equals to 1, it will be 0. And at x is equals to 0, it is again 0. So you are integrating from 1 by 2 to 1. So the graph is symmetric about 1 by 2. This is a parabola which is symmetric about 1 by 2. So therefore, the integration from 1 by 2 to 1 is same as integration from 0 to 1 by 2 because it is symmetrical. Okay. So therefore, we can write this as I22 is equals to integral 1 by 2 to 1 x minus x square whole power 10 dx, and similarly I22 is also is equals to 0 to 1 by 2 x minus x square whole power 10 dx. Now add both of these equations, you'll get 2I22 is equals to integral 0 to 1 by 2, this thing will be there inside, plus integral 1 by 2 to 1, the same thing will be there inside. So there is a continuity in the limits 0 to 1 by 2 and 1 by 2 to 1. So you can simply write 0 to 1 x square minus x whole power 10. X square minus x whole power 10 is x power 10 1 minus x whole power 10 dx. So now x power, so I22 can be written as 1 by 2 integral 0 to 1 x power 10 into 1 minus x whole power 10 dx, but it is in the form of x power p minus 1. So p is equals to 11. Alright, x power p minus 1. So p minus 1 is 10, so p is equal to 11. And here q minus 1. Q minus 1 is also equals to 10. So q is equals to 11. Alright. And so this alpha and beta will be 11 and 11. This gamma will be is equals to 2. Alright. So alpha is equals to 11, beta is equals to 11, gamma is equals to 2. So gamma into alpha plus beta is equals to 44. This is the answer to this question. This is a really beautiful question. So by looking at this infinite limit, you should get the idea that you have to put tan theta and by looking at this expression in the denominator, it will give you tan square theta plus 1, which is secant square theta. So you should strengthen your belief that you have to substitute tan theta for e power x, and then you have to go ahead, and once you do that, once you get sines and cosines, so this is a very standard integral, so you have to substitute for sine theta, and here you have t square, but in the question you have only x. So here you should get an idea that you should substitute some variable in place of t square. So we have substituted p, and once you're done with all of that, once you reach this step, you should draw this graph and realize that this function is symmetric about 1 by 2, and the area from 0 to 1 by 2 is same as the area from 1 by 2 to 1, and then you have to finally convert it into the format into which it is supposed to be converted. All right, so I hope you got something to learn from this question. It is an amazing question that appeared on the sample paper. So let's go ahead with the next question. So this particular question is from the topic complex numbers. So let C be the set of all complex numbers. Consider the function h. It maps from the complex numbers to the complex numbers, and it is defined as h of z. All right, h of z is equals to iz. So now at this point, let us assume z is equals to x plus iy. Then h of x plus iy is equals to I multiplied by x plus iy, which is minus y plus ix. So when you apply this transformation h for any complex number x plus iy, you get minus y plus ix. So let us say this is your Argand plane, which is your complex number plane. So let's say you have a point here, which is x comma y, which is same as x plus iy. When you apply this transformation h, this point x comma y goes to minus y comma x. So this distance is y. So minus y will be somewhere here, minus y comma x. So this distance is x. So x will be somewhere here, x. All right. So this is minus y comma x. So when you apply this transformation, this point went from here to here. If you observe the angle, so if you observe the angle between the line joining these 2 points from the origin, it will be 90 degrees. You can easily check that. Let the slope of this line be m1, slope of this green line be m2. So m1 will be y upon x, m2 will be minus x upon minus y. So when you do m1 multiplied by m2, you will get minus 1. So these two green lines are perpendicular. So applying this transformation h on a complex number is nothing but rotating the complex number by 90 degrees in anti-clockwise direction. So before proceeding into the question, you have to understand what the transformation given is. You have to, understand how the point in an Argand plane gets geometrically transformed to another point. All right. So now we understood what the transformation does to the complex number. H of z is equals to iz. Now let us go ahead and verify the options. The first option says h maps the unit circle. So s is equals to x plus iy belongs to complex numbers such that x square plus y square is equals to 1. So you have a circle given, and the points that are there inside this S are all the points that lie on the circle. So let us consider any point on the circle. So when you apply the transformation h on this particular point, it just rotates by 90 degrees. It comes somewhere here. When you apply it to this point, it comes here. When you apply it to this particular point, it goes somewhere here. So similarly, for if you consider like any point on the circle, and when you apply transformation H on that particular point, it just rotates by 90 degrees, but it lies on the circle. So H maps from S to S is correct. So the initial point is on the circle, and even after the transformation the point lies on the circle, and this holds good for all the points on the circle. So S maps from S, H maps unit circle S to S is correct. Now let us go ahead and verify the second option. H maps the complex upper half plane. So you have to consider the complex upper half plane. So let us consider this particular point. Let us say there is some point here. All right. So this capital H denotes the upper half plane where y is greater than 0. When you apply the transformation small h on this particular point, it gets rotated and it goes somewhere here. It comes somewhere here. So they are saying that this point, like H maps the complex number in the upper half plane, H to H. So we are considering this region initially, points in this region, and we are applying the transformation small h on those points, and they are saying that the transformed points also lie in the same region only. That is false, because when you consider this point and when you apply the transformation, the transformed point will go here and it does not lie in this particular area. So option B is incorrect. Now let us go and check third option. Option C. H maps the unit square centered at 0 to itself. So what is a unit square? Unit square is the square that has the side is equals to 1. All right. So yeah. So this is 1 by 2. This is 1 by 2. This is minus 1 by 2. This is minus 1 by 2. Now when you apply H, this unit square maps to itself, means unit square. Okay. Let us consider any one point. Let us say this point. When you apply transformation on this point, it will be shifted by 90 degrees, but it stays, it comes here. All right. So this length is 1 by 2 here, and there is some height here. So after transformation, this length becomes 1 by 2, and this length will be equal to this length. So take any point on the square and try to apply H on that. You will end up seeing the transformed point also on the square itself. So therefore the third option is correct. Let us verify the fourth option. The fourth option says H circle S, H circle H. What is H circle H? It is simply H of Z. Now it is given in the question that H of Z is I times Z. Now H of Iz can be written as I times of Iz, which is minus Z. So H circle H of Z is equal to minus Z. So H circle H maps. So okay. So let us consider Z is equals to X plus Iy. So when you apply H of H on X plus Iy, you will simply get minus Z. That is minus X minus Iy. So now they are asking us to check this for all the points on the straight line which is passing through origin. So let us say you have a straight line, something like this, that passes through origin. So now consider any point on this straight line. Let us say this point. When you apply H circle H on this point, it goes to minus x comma minus y. Let us say this is x comma y. It goes to minus x comma minus y. Where does minus x comma minus y lie? It is the image of the point in this. It is the image of this particular point in the origin. So it also lies here. If you consider this point, after applying this transformation, it goes here. Let's say if you consider this point on the line, after applying the transformation, it goes somewhere here. So the line maps to itself. Straight line passing through origin maps to that particular line. It is given in the question. So option D is also correct. So the correct options are A, C and D. Now let us move to the next question. So this question is basically about, interpreting what the transformation is, trying to understand what it is geometrically, and then once you have all that information, once you have all that analysis, so you just have to check the options. You just have to consider each option, see where, consider a single point on the given set and see where the transformed point lies. And if the transformed point lies on the same curve, your option will be correct. If it is not, your option will be wrong. As simple as that. So all this question expect from a student is to be mindful and stable while solving. So let us move to the next question. So this question looks very scary. So let us see what it is. It is a multi-correct answer question, MCQ. It can have more than one correct answer. For a function f of x, di f of x by dxi at x is equal to a denotes the ith derivative with respect to x at x is equal to a. Consider m by n matrix A is equal to aij m cross n, where aij is equals to, okay, ai comma j is given. This is ith derivative of x power m at x is equals to 1 divided by jth derivative of y power n with respect to y at y is equal to 1. So before finding the ith derivative, let us find out the first derivative. What is the first derivative of x power m? So that will be d by dx of x power m. So that is simply m into x power m minus 1. So when you put x is equals to 1 here, it will simply be m. So the second derivative will be d square by dx square of x power m, which is m into m minus 1 into x power m minus 2. When you put x is equals to 1 in this, it will simply be m into m minus 1. Alright. So if you want third derivative of x power m at x is equal to 1, it will simply be m into m minus 1 into m minus 2. If you want ith derivative, it will simply be m into m minus 1 into m minus 2 into m minus 3 into and so on m minus I plus 1. Alright. So this is simply m minus 3 plus 1. Here you have 3, so minus 3 plus 1. So here you have I, so minus I plus 1. Alright, this is ith derivative of x power m. Similarly, the denominator is dj by dx of j y power n. So that will be n into n minus 1 into n minus 2 into n minus 3 and so on n minus j plus 1. So now we know what aij is. So we computed the numerator, we have computed the denominator. So now we know what is aij. So now let us compute the matrix. So the matrix is given as ai comma j m cross n. So the matrix will be a11, a12 and so on, a1n, a21, a22 and so on, a2n and so on, am1, am2 and so on, amn. Alright. So a11 is first derivative of this and first derivative of this, so which is m by n. a12 is m by n into n minus 1 and so on m by n into n minus 1 and so on. So here you have to put n, since you have n here. So n minus n plus 1 is 1. So this will be simply n factorial. Alright. So a21, so the second derivative, m into m minus 1 by n. So m into m minus 1 by n into n minus 1 and so on m into m minus 1 upon n factorial. Now let us go and check what the last row is. So am1, So here you have to put m. So in the numerator you will get m factorial by 1. So n. So and this is also m factorial by n into n minus 1 and so on, m factorial upon n factorial. You can just compute what are the values of aij using this formula, and this are computed here. All right, so now this is the matrix that we have. Now let us go ahead. So pi is max of aij for j is equals to 1 to n. So if you want p1, so that is simply max of a 1 comma j for j is equals to 1, 2 and so on n. So this is 1 comma j. When a is equal to 1, that means you have to consider the first row, and j varies from 1 to n, and you have to find out the maximum value. So what will be the maximum value along this row? If you consider this row, all the numerators are same. So whichever term has a minimum denominator, so that term will be the max value. So this is simply this first element. All right. Similarly, if you consider p2, that is max of a 2 comma j. So that is the minimum element in the second row. So that will be this, the maximum element in the second row. So that will be this particular element. All right. So your pi will be the elements of first column. All right. Now let us go ahead and see what qj is. Qj is min of aij for I is equals to min of aij for I is equals to 1 to m. So let us find out q1. Q1 is min of ai1 for I is equals to 1 to m. So when you say ai1, since this 1 is fixed, you have to check the first column. In the first column, you have to find out the minimum element. If you see in the first column, all the denominators are same. So the minimum element will be the element which has the least denominator. So that is this particular element. Similarly, in the second column, this is the minimum element since all the denominators are same. So therefore, your qj will have the elements of first row. All right. Now your p is min of pi. So p is min of pi. So minimum elements among pi. What is pi? Pi is the elements of first column. In the first column, you have to find out the minimum value. So if you check the first column, all the denominators are same. So if you have to find out the minimum element, you have to find out that element which has the minimum numerator. So which is m upon n. Let us go and see what q is. Q is max of qj. So this is simply max of qj. Qj is elements of first row. If you check the first row, you have to find out the maximum element in the first row. So if you check the elements in the first row, all the numerators are the same. So if you want to find the maximum element, the element should have the minimum denominator. So that is m upon n. All right. Now let us go and check the options. So p is greater than q. No, this is wrong, because so here p is m upon n and q is also m upon n. Now a11 less than a22 less than and so on ann. So if your a11 is m upon n, a22 is m into m minus 1 divided by n into n minus 1. a33 is m into m minus 1 into m minus 2 divided by n into n minus 1 into n minus 2. Now what they are saying? They are saying the first element is less than this element, second element, and second element is less than third element, and so on for m greater than n. So m greater than n is given. So this m by n is fixed. So we have m by n here. If m is greater than n, m minus 1 by n minus 1 is greater than 1. So this and this are same, and you are multiplying m by n with something, a number which is greater than 1. So m is greater than n is given in the question. So m minus 1 is greater than n minus 1. So m minus 1 by n minus 1 is greater than 1. So this quantity is greater than 1. So you are multiplying this particular thing with something greater than 1. So this is bigger. By similar argument, m minus 2 by n minus 2 is greater than 1. So you have this whole quantity here, and you are multiplying this whole quantity with something greater than 1. So this statement is correct. am comma n is equals to am minus 1 comma n minus 1. So am comma n is m factorial upon n factorial. am minus 1 comma n minus 1 will be somewhere here. All right. So they're talking about this particular term when am comma n is given. am minus 1 comma n minus 1 is this particular term, and m minus 2 comma n minus 2 is this particular term. So they are going in this direction. All right. So this term is m factorial by n factorial. This term will be, so okay, the last term is m factorial by n factorial. So m into m minus 1 and so on into 2 into 1 by n into n minus 1 and so on into 2 into 1. All right. So this particular term will not have these ones. All right. Since you can check here. So here you have m. Here you have m into m minus 1. When you go down, you'll go till m into m minus 1 and so on into 1. So in the previous row, it will go till 2 only. All right. So this particular term will be m into m minus 1 and so on into 2 by n into n minus 1 and so on into 2. So this is am minus 1 n minus 1. Similarly, this term will be m into m minus 1 and so on into 3 by n into n minus 1 and so on into 3. So this is am minus 2 n minus 2. So now they are saying this and this are equal. So yes, they are equal. So here this 1 by 1 is not there here, and here this 2 by 2 is not there here. So they are always equal. All right. So this option is correct. A is symmetric matrix if m is equals to n. So now they are saying m is equals to n. All right. So then, so you don't have to worry about the diagonal elements. Just consider these two elements. So if these two elements, so what is the property of a symmetric matrix? If you have a 3 by 3 matrix or any matrix like this, these two elements have to be equal, these two have to be equal, and these two have to be equal for a matrix to be symmetrical. So let us verify for these two elements. So that is m by, when m is equal to n, so the denominator becomes m into m minus 1. So even here, m into m minus 1 by m. So this is becoming 1 by m minus 1 and this is becoming m minus 1. So these two elements are not same. So it is not symmetric. So this option is incorrect. So let us proceed to the next question. Again, this is an MCQ based question, meaning which it can have more than one correct answers. And here you are given a function f which maps from open interval minus 1 to 1 to the entire set of real numbers. And the function is defined as f of alpha is equals to minus pi to pi 1 upon 1 minus alpha cos theta d theta. And it is also given that mod alpha less than 1, which means minus 1 less than alpha less than 1. So this is given to us. So now let us consider this particular definite integral. It is a very standard integral. So you have a term which is something like 1 minus 2 cos theta, 1 minus 3 cos theta, something like that. So you don't have to worry about alpha here. So let us go ahead. There is a standard approach to solve these kind of integrals. So the approach is to substitute cos theta is equals to 1 minus tan square theta upon 2 by 1 plus tan square theta upon 2. Alright. So when you do that, So your f of alpha becomes minus pi to pi 1 upon 1 minus alpha into 1 minus tan square theta upon 2 divided by 1 plus tan square theta upon 2. So take the LCM and solve it. So you'll get minus pi to pi. In the numerator, you'll get 1 plus tan square theta upon 2 d theta divided by, in the denominator, you will get 1 minus alpha plus tan square theta by 2 multiplied by 1 plus alpha. Alright, you'll get this in the denominator. So let us rearrange it a bit in the denominator. So minus pi to pi 1 plus tan square. So 1 plus tan square theta by 2 can be written as secant square theta upon 2 d theta by, so this can be written as 1 minus alpha by 1 plus alpha plus tan square theta upon 2. So this whole thing is multiplied by 1 divided by 1 plus alpha. Alright. Now what can we do? Let us do one thing. So let us put tan theta upon 2 is equal to p. Then you'll get secant square theta by 2 multiplied by 1 by 2 d theta is equals to dp. Alright. So now you have 1 by 1 plus alpha. When theta is equals to minus pi, tan theta by 2 will be tan of minus pi by 2, which is minus infinite, and this becomes infinite. So secant square theta by 2 d theta is simply twice of dp divided by 1 minus alpha plus 1 plus alpha plus p square. So let us rewrite under 1 minus alpha by 1 plus alpha as square root of 1 minus alpha by 1 plus alpha whole square. So let us consider this thing as some constant m. So you have 1 by 1 plus alpha integral minus infinity to infinity 2 dp by p square plus m square. So this is a standard integral and you know the value of it. So 1 minus alpha by 1 plus alpha 1 by a square plus x square. So that will be 1 by m tan inverse of p upon m. Alright. Now your m is square root of 1 minus alpha by square root of 1 plus alpha. So this is 1 minus alpha, this is 1 plus alpha. Alright, so this and this gets cancelled and you'll have 2 by square root of 1 plus alpha into 1 minus alpha inside the square root. So this is 1 minus alpha square. And this is tan inverse of p upon m. And we have to apply the limits minus infinite and plus infinite. So when you put p is equals to minus infinite, so you will get tan inverse of infinite, which is pi by 2, minus when you put p is equals to minus infinite, you will get minus pi upon 2. So this is pi, so this whole value is 2 pi upon 1 minus alpha square. So we got that f of alpha is equals to 2 pi upon 1 minus alpha square. So your f of alpha is simply 2 pi upon 1 minus alpha square. Now let us check the options. So your first option says integral 1 upon 2 to 1 by root 2 fx dx. So this is f of alpha. So fx will be 2 pi upon square root of 1 minus x square dx. So 1 by root 1 minus x square. This is simply the derivative of sine inverse of x. So the value of the integral will be 2 pi sine inverse of x. Now you have to apply limits. So when you put x is equals to pi 1 upon root 2. Sine inverse 1 upon root 2 will be pi by 4 minus, when you put x is equals to 1 upon 2, sine inverse 1 by 2 will be pi by 6. So this is 2 pi into 2 pi upon 24. So this is pi upon 12. So 2 ones 2 6. So this is simply pi square divided by 6. Alright. So the first option is wrong. So let us check the second option. So it is given that alpha is equals to root 3 by 2. So let us find out f of root 3 by 2. F of root 3 by 2 is 2 pi upon square root of 1 minus 3 upon 4. This is simply 1 upon 4, which is equals to 4 pi. So now they are asking you to find out tan of f of alpha. So f of alpha is 4 pi. So tan of n pi is simply 0. So this is 0. So therefore option B is correct. Next option is, so let us check the D option first. So again, this is about integral. So they're asking you to integrate, so f of x between 0 and 1 upon 2. So 2 pi comes out, and integral of 1 by root 1 minus x square is simply sine inverse of x. So just put the limits. So 2 pi sine inverse of 1 by 2 is simply pi upon 6 minus sine inverse of 0 is 0. So this is 2 pi square upon 6, which is same as pi square upon 3. So option D is also correct. Now let us go to the third option. The third option says there does not exist any alpha belongs to minus 1 comma 1 such that cos inverse of beta is equals to alpha. Cos inverse of beta is equals to f of alpha. All right. So what is f of alpha? F of alpha is this particular function. So it is also given in the question that minus 1 less than alpha less than 1. So therefore this denominator, so therefore alpha square always lies between 0 and 1. Alpha square lies between 0 and 1. When you subtract alpha square from 1, this quantity, this denominator is less than 0. Therefore this f of alpha is greater than 2 pi. Alright. So you got f of alpha is greater than 2 pi. But f of alpha is equals to cos inverse of beta. So what is the maximum possible value of cos inverse of beta? It is pi. But this f of alpha is, the minimum value of f of alpha is 2 pi. So therefore these two can never be equal. Therefore this beta does not exist. Alright. So this option is also correct. So this is a classic JEE flavored question. I mean, like, there is nothing extraordinary that you have to do in this question. So you just have to solve this integral, and you have a very standard approach to do that. And then once you do that, once you find f of x, it is just evaluating two definite integrals and just putting a value and checking whether the option is correct or not. So let us proceed to the next question now. So this is the next question that we are going to solve. So this was there in the numerical section of the sample paper. So you have two lines given, R1 and R2, and F be the family. So let's say you have two lines and F be the family of all circles that has point on L1. So there's one point here and as well as a point on L2. There is another point here. Let C be the circle with radius R that has smallest radius among the circles. So in F there are two lines. So you have to draw a circle like this that has a smallest radius between these two lines. Alright. So let us see what these lines are. If you check the vectors here, you will realize that these two lines are not parallel, and also these are not perpendicular lines as well. Alright. So these are not parallel lines, these are not perpendicular lines. So if you observe carefully, you will figure out that these two are skew lines. So you have two skew lines like this, and you have to find the you have to take one point on one skew line and another point on another skew line, and you have to find the radius of the circle with a condition that the radius has to be minimum. So how do you do that? So let us say this is a point on L1 and this is a point on L2. So to minimize the radius, you have to minimize the diameter of the circle. So let us say the diameter of the circle is the line joining L1 and L2. So you have to find the minimum diameter circle. So to do the minimum diameter circle, you have to find the shortest distance between these two skew lines. So your diameter will be shortest distance between the skew lines. And once you find the shortest distance, divide that by 2 to get the radius of this circle. So this is a very, very easy question. I would say it is a mains level question, JEE mains question. The only thing is you have to interpret the question properly and understand and realize that they are asking you to find the shortest distance between two skew lines. All right. So let us proceed to the next question. So this is an MCQ based question. So it can have more than one correct answer. All right. And the question is from the topic conic sections, especially ellipse. So let be an ellipse F1 and F2 be 2. It's 2 foci. So you have an ellipse like this. So let us make an ellipse. So you have an ellipse like this. All right. This is major axis, that is minor axis. Okay. And there are its foci. So like the key to solving any coordinate geometry question is to make a good diagram out of it. So always make sure you interpret the information correctly and make a proper diagram. So let F1 and F2 be its 2 foci. Okay, so let's say this is F1 and this is F2. So let P be the point on the circumference of the ellipse that is neither on the major axis nor on the minor axis. So let us say there is a point P here. This point should not be on major axis and should not be on minor axis. That is clearly given in the question. So let PF1 intersect the ellipse again at Q. So PF1. So you have to basically draw this, and this point is Q. And let PF2 intersect the ellipse again at R. So this is R. Then which of the following statements is true? So this is the information given to us, and let us go ahead and check the options. So now the perimeters of the triangle PF1R, PF2Q are not equal. So I'll highlight the triangles PF1R. So this is one triangle PF1R, and we have to consider another triangle PF2Q. PF2Q. So there is this white triangle and that red triangle. All right. So what is the perimeter of PF1R? Perimeter of PF1R is equals to, so it is simply PF1 plus F1R plus RF2 plus PF2. All right. If you carefully observe, PF1 plus PF2, this is the sum of the distances of a point on the ellipse P from its foci. So that is the basic definition of ellipse. So that will be 2a, where a is the semi-major axis. And if you consider F1R and F2R, so that is the sum of the distances of the point R from the foci of the ellipse. So this is RF2. So again, this is also 2a. So this is 4a. Similarly, if you find the perimeter of PF2Q, you will end up getting the same 4a. So the perimeters are equal. Therefore, the first option is not correct. All right. Now, let us go ahead. So let us check the third option. The perimeters of the triangle PF1R, PF2Q are bisected by F1, F2. So F1, F2 is a line. So they are saying PF1R. So this particular triangle PF1R, this perimeter is bisected by F1, F2. So upper half has 2a and lower half has 2a. So that is correct. Similarly, for the other triangle also, F1, F2 bisects the perimeter. So option C is correct. Two lines F1, F2 and QR are always parallel. So now this is what you have to check. So do you think they are parallel? So let us say, so just by looking at the diagram, you can say that they are not parallel. So just by looking at the diagram, you can say, do you think they are parallel? So just by looking at the diagram, you can say they are not parallel. So let us consider the point P here. All right. So let us consider the point P here, and you have F2 here, F1 here, F1, F2. So P F2 goes like this, P F1 goes like this. So your QR forms something like this. So this is F1, F2 and this is your QR. So they are not parallel. So F1, F2 is parallel to x-axis. This is not parallel to x-axis. So the statement that they're always parallel is incorrect. So option D is wrong. Now let us check the second option. So the areas of triangles PF1R and PF2Q are equal if and only if F1, F2 is parallel to QR. All right, if and only if. So we have to check two statements here. So the first thing is areas are equal if F1, F2 is parallel to QR, and the second statement is F1, F2 is parallel to QR if areas are equal. All right, so let us consider F1 is parallel to F2 initially. All right, F1 is parallel to F2. Let us say F1 is parallel to X2. So this is your F1, this is F2, P, Q, R. So this is your QR. So F1 is parallel to F2. So let us consider that this is true. Now we have to find out the area of triangle PF1Q. So let us join these two. So if F1, F2 are parallel, so let us consider this particular trapezium. All right. So let us consider, so F1, F2, Q and R. So this is a trapezium since these two are parallel. All right. So then the area of, what is the area of this triangle? QF2, this triangle. What is the area of this triangle? So it is half into QR multiplied by height. And what is the area of this particular triangle? RF1Q. So what is the area of that particular triangle? So that is also half into QR multiplied by H. So therefore, let us consider the total area of triangle PQR. Total area of triangle PQR is delta. So delta minus area of this particular triangle. So delta minus area of this particular triangle is area of your PF1R. So let us say area of this triangle is delta 1, and delta minus area of this particular triangle is area of your triangle PF2Q. So the area of this white triangle and this red triangle are equal. We have proved it here. So this is also delta minus delta 1. So this is area of PF1R. This is area of PF2Q. Therefore, if F1, F2 is parallel to QR, their areas are equal. All right. So let us go otherwise. So let us say the areas are equal. So you have a figure like this. So let us say the areas are equal first. All right. So this is F1, this is F2, this is P, this is Q. In the exam, you should not be drawing all of this these many times. All right. So just for your understanding purpose, I am drawing it like again and again, just for the sake of clarity. But in the exam, you should quickly realize all these things. All right. So let us consider the areas are equal. So let us say Pf1r is delta 1, Pf2q is delta 2. These are the areas. So since we are considering areas are equal, so let us say both are delta 1 and delta 1. So then what is the area of this triangle R F1Q? So that is simply total area delta minus Pf1R delta 1. Alright, then what is the area of this particular triangle R F2Q? So that is also total area minus area of triangle Pf2Q, that is delta 1. So when you consider these areas as equal, so you will end up getting these areas also equal. Alright. Therefore, since these two triangles lie on the same base QR, so if these two areas are equal, their heights also has to be equal. So this height and this height, their heights has to be equal. Therefore, if these two heights are equal, this line and this line are parallel to each other. So therefore, if areas are equal, F1, F2 is parallel to QR. So therefore, this statement is also correct. So your correct answers are option B and option C. All right. So let us proceed to the next question. So let us go ahead with the next question. So again, this is a paragraph based question. So we are given a function which maps from 0 to infinity to real numbers, and then there is this particular set, two sets given to us. So 0 less than y less than or is equal to f of x for 0 less than x less than alpha. So let us draw the graph of that. So let us say there is a function f of x. All right, let's say this is f of x. Then so 0 less than x, 1 less than x less than alpha. So let us say this is 1. Let us say this is alpha. Alpha is greater than 1. It is given in the question. So the range of alpha is 1 to infinite. So R alpha is this particular region. Alright, R alpha is this particular region. Next, S alpha is 0 less than y less than or is equal to f of x, and alpha less than x less than or is equal to alpha square. So let us say you have alpha square here. So since alpha is greater than 1, so alpha square lies towards the right side of alpha. All right, so this is S alpha. So this red region is R alpha and this white region is S alpha. All right, let us proceed. So let S be the set of all continuous functions f for which the area of R alpha is equal to S alpha. So therefore R alpha is equal to S alpha is given to us. So what is R alpha? R alpha is simply integral 1 to alpha f of x dx. This is equal to S alpha. S alpha is integral alpha to alpha square f of x dx. All right. So now we have to observe this very carefully. So let us see, like when you solve this particular integral, you will get something in terms of alpha because your upper limit is alpha, and similarly the same with this. So you have a function of alpha on the left hand side and you have a function of alpha on the right hand side, and we have to find f of x. All right, so therefore, so let us do one thing. Let us differentiate this on both sides. So to differentiate an integral, you have to use Leibniz rule. So on the left hand side, you will get f of alpha is equals to, on the right hand side, you will have f of alpha square, and the derivative of alpha square is 2 alpha minus f of alpha, and the derivative of alpha is alpha. So this is 2 times f of alpha is equals to 2 times alpha multiplied by f of alpha square. So we are not able to find out f of x, but we got a relation for x. So let us replace alpha with x. So this is simply this thing. This kind of relation in terms of x is called as a functional equation. Now we have to solve this functional equation in order to, find out what f of x is. So let us multiply this functional equation on both sides by x. So why did I do this? Because if you consider g of x is equals to x into f of x, all right. So when you put alpha, you'll get g of alpha is equals to alpha into f of alpha, and when you put alpha square, you'll get alpha square into f of alpha square. So you are making that this sort of pattern here. So you have this function g of x, which is x into f of x, and when you put g of alpha, you will get this left hand side, and when you put x is equal to alpha square, you will get this right hand side. Of course, you have to multiply this with alpha on both sides to match the functions. All right. So now you have this particular relation. So now, so you have your function. So we know g of x is equals to x into f of x. So you have your function g of x like this, and here you have x and here you have x square. So this value and g of x square is simply this thing, this value. These are both same. All right. Let us say you have a function like this, and this is g of x and this is g of x square. So this is your g of x and this is your g of x square. So they are both same. So they should be equal to some value. All right. Some constant value. So let us say that constant value is k. All right. So now by equating these two, you will get that f of x is equals to k upon x. All right. Now we have to figure out what k is. So to do that, let us proceed into the question number 15. So for x belong to real numbers, step of x is the greatest integer less than or equal to x. Let f belong to s. So this f belongs to s. S is the set of all continuous functions for which this thing holds. So therefore f belongs to f looks something like this, k upon x, and it is given that f of 1 is equal to 4. So f of 1 is equals to k, therefore k is equals to 4. All right. Therefore for the first question, f of x is equals to 4 upon x. And now if the area of region R10 is equals to a, so area of region R10 is simply integral 0 to 10 f of x dx. So this area is a. So this is equals to a. So now we have to find out integral part of a. So this is simply 0 to 10 4 upon x dx. This is 4 ln x 0 to 10. Sorry, 1 to 10. The limits are 1 to 10. It is given in the question, 1 to 10. Now it is simply 4 ln 10 minus 4 ln 1 is 0. All right. So you just have to find the greatest integral value of this. So and that will be your answer. All right. So let us proceed to the second question now. So in the first question, we got f of x is equals to k upon x. This f of 1 is equal to 4 is given in the question. So therefore we cannot fix the k value. So we will be considering f of x is equals to k upon x. So let f belongs to s. So f of 1 is equal to 1, that is given here. So therefore k is equals to 1. Therefore for this question, your f of x will be simply 1 upon x. Now it is also given that g of x is limit n tends to infinite 1 upon x to n f square of t cos t dt for any x greater than 0, and g of 0 is 0. This is also given. Now what do you have to find out? So you have to find out limit h tends to 0 g of 1 upon pi minus g of 1 upon pi plus h divided by h. So you have to find out this particular limit. So this looks very scary, But this is a very simple thing. So what is the definition of a derivative? So let us say you have a function f of x, then your f dash of x is limit h tends to 0, f of x plus h minus f of x divided by h. This is the definition of derivative. So now if you compare these two, you will realize that this is simply minus g dash of 1 upon pi. All right. So you can do that comparison. You can pause this video at this moment and compare it. So all you have to find out is minus g dash of 1 upon pi. You have to find out this. So g of x is simply limit n tends to infinite 1 upon x to n. F square of t is 1 upon t square. This is simply cos t upon t square dt. All right. So therefore your g of x is simply 1 upon x to infinite cos t upon t square dt. Now let us differentiate it on both sides. All right. So you have to follow the Leibniz rule. So g dash of x is when you put infinite and do all of that, it becomes simply 0 minus cos of 1 upon x by 1 upon x whole square into minus 1 by x square. Alright, so this and this gets cancelled, this minus and this minus, they will become plus. So therefore your g dash of x is simply cos of 1 upon x. Alright, so now you have to find out g dash of 1 upon pi. So that is simply cos pi. So what is cos pi? So cos 0 is 1, cos pi is minus 1, and so you have to find out minus g dash of 1 upon pi. So that is simply is equals to 1. All right. I feel this is the most this is one of the trickiest and difficult questions in the whole sample paper. So yeah, let us go ahead and solve this question. So you have two functions given, f of x. So f of x is simply 3x plus 4 cos x, and g of x is 6 pi into x minus 1 whole square. Now you have to find out the number of local maxima and number of local minima of f circle g of x. That is simply f of g of x. So to find the maxima and minima points, so let us say f circle g of x is h of x. So to find the maxima and minima point, you have to find out h dash of x, and once you find out h dash of x, you can use wavy curve method to classify the maxima and minima points. If you don't know what wavy curve method is, I have explained it in the previous videos. I'll leave the link to those videos in the description and in the end screens as well. You can go and check it out. So let us find out what h of x is first. H of x is f of g of x is 6 pi into x minus 1 whole square. So now this is f of x. So in place of x you have to put this. So that is simply 3 into 6 pi multiplied by x minus 1 whole square plus 4 cos 6 pi multiplied by x minus 1 whole square. Alright. So now this is simply 18 pi into x minus 1 whole square plus 4 cos 6 pi into x minus 1 whole square. Now we have to find out h dash of x. So let us differentiate this. Then you will get 18 pi into 2 into x minus 1 plus 4, the derivative of cos is minus sign, 6 pi into x minus 1 whole square. Now we have to take the derivative of this inner thing. So that will be 6 pi into 2 into x minus 1. So this is simply 36 pi into x minus 1 minus, so this will be 4, 6 are 24, 2 is 48. 48 pi into x minus 1 into sine 6 pi into x minus 1 whole square. So now this is, if you take out 48 pi into x minus 1 common, so you will get 3 upon 4 minus sine 6 pi into x minus 1 whole square. Alright, so this is h dash of x. So now we have to find out First we have to find out the number of critical points of this function. So it is given in the question that x lies between 0 and 2. Alright, x lies between open interval 0 and 2. Therefore, when x lies between 0 and 2, so this is one critical point that we get. So x is equal to 1. So we have to find out the number of roots of this particular thing when x lies between 0 and 2. So let us draw the graph of this first. 6 pi into x minus 1 whole square. So that is a quadratic equation. So let us say this is x is equal to 1, this is x is equal to 0, and this is x is equal to 2. This quadratic equation is symmetric about x is equal to 1. Alright, something like this. At x is equal to 0, it is 6 pi, and x is equal to 2, it is 6 pi. Alright, now we have to check where this becomes 0. That becomes 0 when sine of 6 pi into x minus 1 whole square is equals to 3 upon 4. This is 6 pi into x minus 1 whole square. Alright, so now when x runs from 0 to 2, alright, sine this whole quantity changes from 6 pi to 0 and again goes from 0 to 6 pi. Alright, so therefore this sine function, so initially at x is equal to 0, it will be at 6 pi. Alright, the sine function, it will be at 6 pi. Sine 6 pi is 0. When x is equal to 0, this inside thing becomes 6 pi. Sine 6 pi is 0. And then again from 6 pi to 0, this internal value changes from 6 pi to 0. So this red value changes from 6 pi to 0. So therefore this sine curve goes from, so as it goes from 0 to 1, it changes from, so you'll get three curves like this. So it started at 6 pi, somewhere in the middle you'll get 5 pi also, and somewhere you'll get 4 pi, somewhere you'll get 3 pi, somewhere you'll get 2 pi, all of that. And all of those things, sine 6 pi, sine 5 pi, sine 4 pi, all those things has the value of 0. So at x is equal to 0, you got 6 pi, and for some value of x, you'll get 5 pi, that is this point. And for some other value of x, you'll get 4 pi. So that is this point. For some other value of x, you'll get this internal value as 3 pi, and that is this point. And by the time you reach 1, so this will be 0. This is sine 0. Now again it goes from 0 to 6 pi. For some value of x here, you'll get pi. For some value of x here, this internal value will be 2 pi. So again it goes from 0 to 6 pi. So this is pi, 2 pi, 3 pi, 4 pi, 5 pi, something like that you will get. So your sine wave will look something like this. Alright, let's say this is the graph. Let's say here x is equal to 1 is there. Before x is equal to 1, your sine becomes 0 6 times. So 1, 2, 3, 4, 5, 6. This point is your x is equal to 1. And after that again it becomes 0 6 times. 1, 2, 3, 4 and 5, 6. Alright. So now this whole quantity becomes 0 when x is equal to, no, when this whole sine value becomes 3 by 4. So 3 by 4 lies somewhere here. Alright. So this is x is equal to 0 and this is x is equal to 2. So therefore this becomes 0 at 12 points. So we got 12 critical points. Alright. We got 12 critical points. And this x is equal to 1 is one more critical point. Alright. Now let us consider this point. Just before that point, x is less than 1. So this is negative. And 3 by 4 is greater than the sine curve. So this white line is above the sine curve. So this is positive. So before this point, h dash of x is negative. And after this point, just after this point, x is less than 1. So this quantity is negative. But 3 by 4 is less than sine x. So this is also negative. So after the point this is positive. So, and similarly, if you check this point, it will change from h dash of x changes from positive to negative. For this, negative to positive. For this, positive to negative. So when the slope is changing from negative to positive, it is a minima. And when the slope changes from positive to negative, it is a maxima. So this will be your minima. This will be your maxima. Again, this will be your minima. This will be your maxima. Now, what is this point? Similarly, this is minima, this is maxima, this is minima, this is maxima, this is minima, this is maxima. So we have 6 minimas, 6 maximas. Now, we have not considered this particular point. Now, let us check what this point is. Before this point, x is less than 1. So, therefore, this part is negative. And before this point, 3 by 4 is greater than sin x. So, therefore, this is positive. And after this point, x is greater than 1. And this quantity is still positive. So, it changes from negative to positive. H dash of x changes from negative to positive. So, it is also a minima. So, therefore, we have 7 minimas and 6 maximas. 7 minimas and 6 maximas. So, your m is 6 and n is 7. So, you're asked to find out 2m plus 3n. So, this is simply 12 plus 21, which is 33. So, 33 is your correct answer. So, this analysis, so you should be able to draw this graph. You should be able to realize that as x changes from 0 to 2, this internal argument of sign changes from 6 pi to 0 once and then 0 to 6 pi once again. So, you'll get 6 pi, 5 pi, 4 pi, 3 pi, 2 pi, pi, 0 and again pi, 1 pi, 2, 3 pi, 4 pi, 5 pi and 6 pi. So, you should be able to draw this graph and classify maxima and minima points. Alright. So, this method is explained in my other videos as well. So, make sure you watch those videos, and these kind of questions actually appeared in your JEE exams. Alright. So, yeah, let us go ahead. That marks the end of this video. So, I have tried to explain each concept from each question in a very detailed manner. So, if you have liked the video, or if you have liked the content that I am making in general, so do hit that like button, share it with your friends and subscribe for more such content. And if you want to suggest something, you can comment it down below, or you can join the Telegram channel, the link to which is given in the description, and you can check out my other videos as well. So yeah, meet you in the next video. Bye.